In the previous lecture, we studied about the halting problem, and we said that the halting problem is undecidable. Now, in this lecture, we will see more on the undecidability of the halting problem, and we will see how can we prove that the halting problem is actually undecidable. Alright, so the halting problem was, given a program, will it halt? So our question was, can we design a machine which can tell us whether a given program will always halt or not? So this was our question. Can we design a machine which, if given a program, can find out or decide if that program will always halt or not halt on a particular input? So this means that can we design a machine in such a way that if we give a program to that machine as an input, then that machine should be able to tell whether that program will always halt or not halt on a particular input to that program. So this was our question, and we said that this is undecidable and we cannot design such a machine. So in order to prove this, we will prove this using contradiction. And in order to prove this using contradiction, what we will do is we will first assume that yes, we can design such a machine. So we will assume that such a machine actually exists. So let us assume that we can. So if we assume that we can design such a machine, and let's say that I call that machine H, or I call that program H, and that H, it takes two arguments P and I. So P is the program and I is an input. And on taking a particular program P and I as the argument, this machine H or this program H will tell that this program P will either halt or not halt. So we assume that this actually exists. So to this machine H, if we pass program P and an input I, it will tell us whether it will halt or not halt. So if we can design such a program, then this allows us to write another program. So here is that program, and I call that program C, and C takes as an argument X, and X is any program. And this is the definition of this function or program C. And what do I do? In this program C, what I do is that I call the program or function H, which we already defined over here, H, and to H I pass arguments X, X. So we see that H can take two arguments P and I. So P is a program and I is the input. So I pass this program X as the program, and also as the input I pass X. So both the program and the input are X in this case. So we call this function H with arguments X, X. And we know that this program H, it will give us two outputs. It will either say that a given program will halt or it will not halt. So I'm going to have two conditions over here. So I'll say that if H gives the output as halt, that means if H tells me that X on input X is going to halt, then I am going to write a loop which will loop forever. I am going to write something that will loop forever. Alright, I can do this. So if H on input XX is going to halt, then I am going to write something that will loop forever. And else means if this gives me output not halt. That means if I pass XX to the function H, and if it says that it does not halt, that means if it does not halt. So what I will do is I will say return, and return is something that will actually halt. That means that if this is not going to halt, then I write something that will actually halt. Alright, so what I am doing here is if this will halt, then I am going to write a loop that will go forever. And if it does not halt, then I am going to write some statement that will actually halt. So this is the function C that I have. Now let us see what will happen if I run C on itself. If I run C on itself, let us see what will happen. And here we can see that we are going to have a contradiction. Alright, so let's see if we run C on itself, then what will happen. So we have this C and I run it on itself. That means this was the function C, and in C it takes the argument X. So instead of X, I passed C itself. Yes, we can do something like this. This is possible. So if I run C on itself, So let us see what is going to happen. So this is the function of C. So let us look here and see what will happen. So we see that in C there are two possibilities, this if part and the else part. So let us write down these two possibilities. So in the if part it says if h of xx equal to hold. So here when we pass x, we have x over here, but here in C I am passing C itself. So instead of xx I will have cc. Now if it will hold, so if cc will hold, then what happened? I am writing something that will loop forever, and loop forever means this is something that will not hold. So it is something that will not hold. So here is the contradiction. If I run C on itself, and if it does not hold, my H is telling me that it is going to hold. So this is a contradiction. This does not make sense. When C is actually not holding, H tells me that no, it will hold. So H is wrong. Now let us see the next condition, the else part. So else part says that if this one does not hold, so if H of xx does not hold, so instead of x we have C, so H of cc does not hold, then we return something. And by returning we mean that this is not an infinite loop, it is something that will hold. So this return part means it will hold. So it says it holds. Now again we see that we have a contradiction. When we run C on C itself, and when it says that it holds, H is telling me that it does not hold. So again I see that H is wrong. So this does not make sense. When it says that it does not hold, H says that it holds. And when it says that it holds, H says that it does not hold. So this does not make sense, and this shows that H is wrong. And why is it wrong? That is because we were wrong in the first place by assuming that H actually exists. We assumed in the beginning that H actually exists, but we see by contradiction over here that H cannot be right. H does not exist. We cannot have a machine or a program H which will tell us that a program will either hold or not hold. So this shows us by contradiction that the halting problem is undecidable. That means we cannot design a machine which will take a program and say that that program will always hold or it will not hold. So this proves the undecidability of the halting problem. So this is how you prove that the halting problem is undecidable. So I hope this was clear to you. Thank you for watching and see you.